Okay, we want to talk about gyres, large circulations of ocean water that occur. First, you have it's not the greatest copy, but you've got a black and white copy of a world map showing you the major circulations that occur throughout the world. You have a large circulation of ocean water in the South Pacific. You have another one in the North Pacific. You have one in the North Atlantic, one in the South Atlantic, and one in the Indian Ocean. And if you notice, the ones that are in the southern hemisphere all turn to the left, or you could say that they are oriented in a counterclockwise direction. The ones in the northern hemisphere turn to the right or are oriented in a clockwise orientation. Okay? All right, but we need to talk a little bit more about currents and where we find those, the difference between warm currents and cold currents, some things like that. Okay, on the other side of your paper, you have this world map. And what I would like for you to do is take a red marker and mark all of your warm currents with a red marker. Okay, so after you find your all of your warm currents, you should have them in red. And I'm going to ask you to do the same thing for the cold water currents, except for use a blue marker this time. Okay, so after you get the blue cold water currents drawn in, your map should look something like this. But you notice that there are also some other gray arrows that we need to talk about. And so I want you to take a black marker and trace over those. Those are actually our surface winds that we've talked about previously. And they're going to influence the way that surface ocean currents circulate. So take a black marker and mark those surface winds for me. Okay, so now we have lots and lots of arrows on our map. We need to make sure that we mark somewhere and add to the key that our black arrows represent our surface winds. I'm going to move this over. I want to talk about what those surface winds are called. We touched on them the other day when we were doing investigation 6A. But I want to talk about them and remind you what they are. First of all, the winds that operate between the equator and about 30 degrees north and 30 degrees south, those are called the trade winds. In the northern hemisphere, from about the equator to about 30 degrees, these trade winds generally blow from northeast towards the southwest. You see all of those northeast to southwest arrows. Okay? And so in the northern hemisphere, they are known as the northeast trades. In the southern hemisphere, from the equator down to 30 degrees south, you have the trade winds blowing from southeast to northwest. Southeast to northwest. And so those are known as the southeast trades. Okay. And again, you've got trade winds going from about, your southeast trades are going to be 0 to 30 degrees south. Your northeast trades are going to be 0 to 30 degrees north. Okay. Then we have winds that go from 30 degrees north or south to about 60 degrees. And if you notice, in both of these areas, from 30 to 60 degrees in the northern hemisphere, from 30 to 60 degrees in the southern hemisphere, generally speaking, the winds are blowing from the west. It's not perfectly from the west, but more west to east than anything else, okay, both in the northern hemisphere and in the southern hemisphere. And so these are going to be known as prevailing westerlies. In both hemispheres. Okay. Then we've got one last section for each hemisphere. It's what we've got going on between 60 degrees and the North Pole, and between 60 degrees and the South Pole. And if you notice, again, these arrows don't go perfectly east to west or west to east, but in general, these polar winds blow from east to west in both cases. So they are known as the polar easterlies. In both cases. Now, if you need to, pause this to get your arrows drawn or to get your labels on, and then join me as soon as you do that. What I'm going to do is I'm going to magnify this because I do want to show you one more thing. Alright, one of the last things I want to show you is that we can, if we look carefully, we can actually see these big circulations, those gyres that I talked about, those swirling areas of ocean water. If you look, and you take the warm and cold currents together, there is your South Pacific gyre right there. Okay. Part of it is made up of cold water currents, part of it is made up of warm water currents, and it moves and turns towards the left or counterclockwise because it's in the southern hemisphere. Up here in the northern part of the Pacific Ocean, we have another circulation. That's the North Pacific gyre. Over here in the Atlantic Ocean, we have another circulation. Again, it's using both warm and cold ocean currents. So there's the North Atlantic gyre right there. Here is the South Atlantic gyre. finally, we have one in the Indian Ocean. A circulation set up here. Okay. So a gyre is just a large area of circulating water. And you notice that the ones in the southern hemisphere are oriented like they're turning left. They move counterclockwise. The ones in the northern hemisphere move like they're turning right, clockwise. And they do that because of the Coriolis effect, the fact that the Earth is turning as all of this is happening.